Hello and welcome to section 3.3 derivatives of trig functions. You're going to want to review some trig if it's been a little while. You're going to want to be familiar with the properties of trig functions, the domain, range, and some identities, remembering what the basic characteristics of the graphs. So for instance, with the sine and cosine graph, remember that they're translations of each other. So the sine graph is the same as the cosine graph, shifted pi/2 units to the right. They're periodic, and their range is -1 to 1, and their domain is all real numbers. Tangent and cotangent, you need to remember the definition of those in terms of sine and cosine. And the same with secant and cosecant. So some other things that we'll be using are the Pythagorean identities and the properties of the sine function being an odd function and the cosine function being an even function. And then the last thing that we'll be using particularly in this lesson is the angle sum formulas. So let's start with talking about the derivative of the sine function. If you look at the graph of the sine function, it's this red graph, and the graph of the cosine function is this blue graph. So notice that at the maxima and minima of the sine function, those correspond to the zeros of the cosine function. So that's a strong indication that cosine is the derivative of sine. Also notice that where the sine function is increasing, the cosine function is above the x-axis, and where the sine function is decreasing, the cosine function is below the x-axis. So that's some more evidence. So now let's go look at finding the derivative of sine from the limit definition. So here's my difference quotient with h, and here's where I'm going to use the angle sum formula on the sine of x plus h. I get the sine of x cosine h plus sine h cosine x. And then I'm going to factor sine x out of these, the first and last term. And I'm going to factor cosine x out of this middle term and break this up into two limits. So like we've done before, we're going to notice that sine x in this limit and cosine x in this limit don't have an h in the middle. They do not involve h, so we can factor them out of the limit because the limit as h goes to 0 is not going to affect these guys. So we're factoring those out. So now we're left with the limit as h goes to 0 of cosine h minus 1 over h, and the limit as h goes to 0 of sine h over h. So we need to find out what these limits are to be able to evaluate the limit definition of the derivative of sine. So let's look at these two. So first let's look at sine h over h. I've graphed it here, and you can see that as h goes to 0, or as x goes to 0 from this graph, the function goes to 1. That's because the sine and the sine of h and h, or sine of x and x, are very close to each other for very small values of x. So graphically we determine that this limit, sine h over h, is 1. So now let's look at that other limit, cosine h minus 1 over h. So we're going to talk about this from two different angles. The first being, if we just graph this function, cosine x minus 1 over x, that's this red function, solid function, you can see that as x goes to 0, this goes to 0. So that's enough to tell us that that limit is 0. However, something else to notice, that this limit, if we write that as x goes to 0 of cosine x minus 1 over x, we can recognize that as the difference quotient for the function f of x equals cosine x at x equals 0. So this limit is actually the derivative of cosine when x is 0. But knowing that at 0 the cosine function has a local maximum, we know that that would be 0. So either way you look at it, this guy is 0. So now back to our sine derivation. So we had sine x times 0, which was that limit we just looked at, plus cosine x times the limit of sine h over h. We determined that went to 1. So this just turns into cosine x. So the derivative of sine x is cosine x. Deriving the derivative of cosine x is similar. We can use what we used before by noting that the cosine of x is the sine of x shifted pi over 2 units to the left. So that's this translation. So using the difference quotient again with this representation of cosine x and the angle sum identities again gives us the same type of thing where I have this factor times this limit and this factor times this limit. So we saw that this limit was 1, this limit was 0. So that gives us cosine of x plus pi over 2. And we know that the cosine of x plus pi over 2 is equal to minus sine x.